Well, happy Monday. Yay. We can smile. If you smile, you're not going to break your face. Or more importantly, what facial muscles? Zygomaticus, and there's one more. Starts with a B. Yeah. Yeah, it's right here. Well, I gave you what you asked for. He said, show me where it's at. Yes, your zygomaticus is right here. Buck something. Buccinator, that's right. Buccinator. Come back. I'll be back. No, I'm going to say Terminator, Buccinator. All right. All right, so we're just going to, as the schedule says, review the aromatics and then just discuss your activity that you'll be doing the next couple of days. And then on Thursday, we have that scheduled, okay, as being your third problem evaluation, which then would be these reactions that we're going over. Okay. So I would be led to believe that I don't think I have any papers to hand back. I think you have everything all the way up to, I think it was worksheet 4. I mean, the first one was naming alkenes. The second one was aliphatic reactions, which means some of them have the major and minor products. Number 3 was naming these aromatics, and then number 4 was the reactions themselves. And I think you have that paper back. So how we continue with this then is, okay, just like with any of these aromatics, that's not terrible. Let's see here. Let's try. Maybe I just need to go down further right away. I don't know if that's any better. We'll just have to accept that. Okay. So give me one of, we can't do benzoic acid, so give me one of your common names then. Okay. So then once we designate this as a phenol molecule, what do you want to add to that phenol? We're limited on what we have discussed. This, for our purposes, it's just more so on where some of these molecules will react and where placement, whatever it is you're reacting some of these common names with, how they get attached onto there. We could add, of course, we can do a halogen on there. We could probably put an alkyl group on there. I'm trying to think of what else we could possibly put on there. You could put a nitro group on there. Those are probably your only options. Because the most important aspect about this is once you see this molecule, what is it that we want you to understand right away? Okay, so we know that that's phenol. So let's just go ahead and put an alkyl group on there, for instance. Okay, so if we're going to add that onto there, okay, and then, of course, we need to have something here. So in this case, kind of mix it up a little bit. So once we see this, we know this reaction is going to proceed. And for our purposes at this level, how do we know what's going to happen here. We know we got our catalyst. We know this is going to react, but what we had said, when you get to this stage, why is this significant, the hydroxy group, or OH? Right. It's going to determine whatever it is you're reacting that with is actually going to attach. So in this case, maybe I try to make them too big. I don't know. So our OH group is still here. So are we going to have one or two products with that? Okay. So 2 is correct. Then do we know where they're going to attach? Okay, so when we do this, left or right? Okay, so then I can, you saw me stumble with this too. It happens, okay? What was it? I couldn't count to 4. Good gosh. How hard is that, counting to 4? Well, it's not. It's just when there's the forest, I can't see the trees, but if that's a phrase I've been using lately. They can't see the forest for the trees. But, all right. So when this happens, okay, this breaks apart right there. It doesn't take that part of the 5. Maybe it's just kind of hungry. It's kind of reaches, just grabs that too. Takes a bite out of the 5. No, that's 7, 8, 9. That's what that goes. I knew it was a number joke, but all right. So what are we going to attach onto here? C2H5. And you had correctly said that's not the only product that we get. Okay? And then I guess I don't know why I put these in parentheses. You can just write, if you write just plus signs, of course, there's nothing wrong with that. And then there's our, good gosh, I'm not in that big of a hurry. Okay. All right. Try to make it at least somewhat, on my account, not yours. Try to make it at least somewhat legible. Okay. Okay. Now, if later on you might encounter, maybe you're adding heat to this, but for our purposes, this is as far in depth as we go, because as you had noticed, your chart is full. Are there more reactions that we could do for that? Yeah, I suppose. But where do we stop with that? I mean, it's just one of them aspects to where we're trying to give you a nice wide foundation with that. Okay. So let's see here. What about if we wanted, what about if we just wanted this? If we, I'll just put them up top. I'll leave that open for interpretation for yourself. How are we going to get there? Okay, and I know that's missing a bond, okay, but how are we going to get there?
Start with a benzene.
Okay, benzene ring. Okay.
Add your ethyl and then halogen.
Oh, I'm so glad you said that, because I thought you were just going to say an ethyl group. I was going to say, I got him. Okay. Okay. So you said an ethyl group. That's right. C2. Well, since we had H4 over there, maybe it's H4 here. No, it should be a 5. Okay. One of the reasons we know that, okay, is because we know that each carbon is supposed to have 4 bonds, and right now we're looking at 2 and 3, okay? And then plus we had that up here as well. So the last thing we need then is a halogen, which is what? Okay, we can just put chlorine on there again. Okay. Are we all the way here? This is a little tricky because what we wanted is something similar to this to be on here. Because remember, we said we're one bond short here. We're just not going to slap another hydrogen on there because then we would have the same reaction that we see up here. We're just trying to show a little diversity here. So now we'll go ahead and put this Cl group on here. Okay. So what's going to happen here? It's a trap. It's a trap. Okay, yes, you need a catalyst. Okay, so then, I don't know, nickel chloride. Okay. Do you ever make some of these rings and say, God, I don't like the way that looks? So you erase it and start over? Maybe not. So just like what we saw up here, this disassociates, and then the hydrogen you're talking about is going to grab that chlorine there. So we have our C2H5. So then there's just one step left to get from here to here. Okay, so all we're going to do is we're going to chlorinate that. And then, as you said, a little bit of heat. Once we do that, then we only get one product for that. Is there another way to do alkylation? Because that's what we're doing here is alkylation. Is that the only way to do that? Using acid catalyst and okay. So then, but are you using an alkyl group, or in this case, what is? You pointed the right spot, but what does it say? Yeah, an alkene. Okay. So in that case, okay, we can get the same result. Okay. So we're not going to reinvent the wheel here. We're going to get this attached onto there by doing what? So what would be our simplest alkene? Why don't we do alkenes for just making toluene? So why can't we use an alkene to make toluene? Yeah, you need to have at least 2 carbons. That's right. Okay, so now okay, so we've got our benzene ring, we've got our alkene. We need to take that out and put what instead? Like acid catalyst, and I think probably the most common one. Go ahead and put that there. Okay, so now what can we presume that's going to happen on here now, according to what you have on your chart? It just says that acid catalyst reacts with this double bond, breaks it, and then what happens? Yep, we're going to get the same thing we have down here. So C2H5. So then, and you might be asking, now wait a minute, we had C2H4 here. Okay, well, I would agree. But remember, there was a hydrogen on here that would essentially attach onto there. Then our final step would be, if we want to get this molecule down here, we're going to chlorinate it again. Add what to it? A little more heat. Okay. Okay. So in this case, remember it's not C2H5Cl, it's C2H4Cl. Okay. So this is two different ways to get to the same product on there, because one of the things that we may ask on an evaluation then is illustrate illustrate two ways to make a product like this. And of course, what you do, start in the center with your benzene, get your alkyl group on here. We did that here, we did that up here, and then you want to chlorinate it again, but add heat, and then that will attach onto your alkyl group. Is it more complex than that? Yes, well, of course it is. But for, again, our purposes, it's just the idea of this is what happens. And I think you're going to encounter some of that in college, to where, okay, we have a good background for what we need to know, but you're perhaps going to have to fill in some of the gaps with that. And we talked about that in general chemistry. It could be such a minute detail of significant figures. That's one of the things that maybe some professors are big on, maybe others not so much. So it's just something you're going to have to sort out once you get there. But having the background, that is the more important aspect of it. It's kind of like, I always thought about, it's kind of like scouting when you're doing basketball, volleyball, football, whichever. Okay, we know that this is what's going to happen, but how do we get there? Okay, and that's what you're doing with your scouting when you're watching that film all the time. Okay, just wanted to do a quick review. We're not gonna show you all of our cards on this side, but we're showing you quite a bit. So again, the two biggest things to remember when you're encountering these: one, are we starting in the center? Okay. Then once you've encountered that, oh, we're not starting in the center because there's something attached onto there. Okay. So then whatever it is that is attached onto that ring structure, that's what's going to determine where it's going to attach and what type of catalyst, because heat is going to be different than that of a metal catalyst. Have we confused you enough yet? We on the bus? No, just got ran over by the bus. Zoom. There's one last thing I want to show you about your activity, is talk about it as a group. So I'm just going to pause this for a moment. Okay, now we're back. And I just think it's worth our time to read through this. Again, we don't really want to let this be overbearing. We're on 18 minutes now, so that's not too bad. Okay, so in this procedure, and we had briefly talked about parts of this, and for some people, you're going to want to buy some of these hand creams. No, I don't think so. Okay, we talked about these, the properties of their mixture, whether it's going to be very spreadable, is it going to moisturize the skin, is it going to smell good? Okay, well, that doesn't always happen, especially in this procedure. Okay, so prepare 2 of the following samples as follows. We're not going to do that because what happens is each time you remove one of these, it's going to take away from your overall end product. So here are your main 5 ingredients right here, although you're going to be adding, I think, somewhere I was under the impression we add sulfuric acid to this. Sometimes I can remember this from year to year, others I got to remember. Lanolin, that's probably the most annoying aspect that you have to add because it is a type of, it's an animal fat, really, is what it is, okay? And you have to measure that out. And we want to do 7 grams. Remember, we want to double each and every one of these. So it's 10 grams of stearic acid, 10 grams, 10 grams. God dang. Okay, try again. 10 grams of stearic acid, 7 grams of lanolin, okay, 10 grams of mineral oil, and then 2 milliliters of this triethyl-anilalanine, okay? And then, of course, about 50 milliliters of this water. If you hit 48, fine. If you go up to 50, that's no big deal. Okay, so then one at a time, weigh all of these. Okay, so you have your measurements up here that you're going to dump. Okay, weigh in 1 beaker the specified amount of stearic acid, lanolin, and mineral oil. Okay, because what will happen on Wednesday, one of the things I tried to bring and out that lanolin for you, because that's just one of the things that. And if you have that done already, rather than waiting in line for each and every group trying to get through there, it just speeds up the process. Okay, so you have all these, you're weighing in one at a time. Heat the beaker on a hot plate that has been set at a low setting. We'll have that done for you already. That's another thing. I try to get the hot plates going and get them set at a temperature that will work well for you. Okay. So you're going to heat it on a hot plate until all the ingredients have melted. It's necessary to keep the temperature below 100 degrees, which we will do. The chemicals might decompose if heated to a higher temperature, which means we're going to hamper your results, is what we're trying to say. Then your final step here, okay, you're adding this 24 milliliters of water in this triethyl-anilalanine, these two right here. Okay, place that in a, I don't know if it has to be a 400 milliliter beaker, but place it on a hot plate as well, so you have 2 of them, 1 of all of these, and then 1 of these right here. Okay. And then after the solutions have reached 80 to 90 degrees, remember we'll try to have that set for you already. May take about 4 minutes to on the hot plate, but we'll have that time already set for you. I mean, it'll already be between 80 and 90 degrees, okay? And then what happens is you take, remember there's 2 beakers on those hot plates. And then it just says after the solutions have reached 80 to 90 degrees, okay, but we've done that already, okay, slowly pour the oil into the water a little at a time, stirring continuously. If you pour too fast or if you do not stir, your emulsion will be lumpy, okay. Continue stirring until you have a smooth, uniform paste. Length of time it takes to achieve this with mixture number 1 indicates how long you should stir the other mixtures. But there again, we don't have to worry about that because we're just doing procedure 1, or group number 1. Okay? And then, and of course, we're not comparing the properties. And then what you can do is if you decide to keep it, put your name on it, and then we're not worried about the date. Packaging and labeling, put your best effort into the vial provided, label it with your name, today's date, your instructor's name, and take it home to enjoy. So we're not doing any of that. You can just put your name on it and keep it. And if you don't think it's worth keeping, that's fine too. Just go ahead and discard that. All right. So I think it's important to go through that together as a group. That way, when you're working with the 3rd graders, I think, makes a little more sense, and we're ready and we're more prepared for that. Okay, so I think that's enough. We will catch up to you next time. Oh, you're already riddled with anticipation.
Yeah, I'm ready for it.
Oh, I sound like an idiot when I do that. Well, what's different than any other time? What, like this? Something, I don't know. I'm not a human beatbox. See you tomorrow. I don't know. See you next time.